All right, so chapters 4 and 5 are on discrete random variables, that's chapter 4, and continuous random variables, that's chapter 5. Okay, so lessons 7 and 8 are going to be on discrete random variables, and then lessons 9 and 10 will be on continuous random variables. So we're focusing in this lesson on discrete random variables, but it's easier to understand, well, one way of understanding discrete random variables is if they're compared to continuous random variables. So think about discrete random variables. Here are some examples. For example, the number of people on an airplane. You could have 185 people on an airplane, you could have 78, you could have 231, okay? But you know what you can't have on an airplane? You can't have 183.7 people on an airplane. That's not possible. We do not count human beings in decimals. We count them in whole numbers, okay? On the other hand, we can measure how long a flight is, how many hours a flight is in decimals. We can say that a flight is 2.387 hours. We can use decimals. And that's the main difference between discrete random variables and continuous random variables. In general, discrete random variables are counted in whole numbers, where continuous random variables can be measured in decimals. Another example, how many bedrooms in a house? A bedroom can have 2 bedrooms, 3 bedrooms, 4, 5, 6 bedrooms, okay? But you can't have 4.789 bedrooms in a house. That's not possible, okay? You either have 4 bedrooms or you have 5 bedrooms. Now they may not be the same size, but we're not considering size. If you want to consider size of the bedroom, then you're going to go to a continuous random variable. For example, the square footage of a bedroom might be 187.64435 square feet. That would be a continuous random variable because it's being measured in decimals. So discrete random variables are counted generally with no decimals. 43 of them, 44 of them, 45 of them, etc. But continuous random variables, they are measured, and they are often, usually, frequently measured in decimals. So for example, Heritage High School is 3.82 miles away from RCA. That is a decimal measure, 3.82 miles. Okay, so basically any variable that is counted in separate whole number units is a discrete random variable. And any variable that can be measured to include decimal values, that is what we call a continuous random variable. And in lesson 7, we're going to focus on discrete random variables. So let's talk about a discrete random variable. We're also going to use the phrase DRV, discrete random variable distribution. Oftentimes we can identify a discrete random variable and the distribution of a discrete random variable in a table, which we sometimes call a frequency distribution. And in this table you can see we have one row that's x, one row that's f of x, and one row that's p of x, okay? So x is the discrete random variable that can take on different values, okay? And like we said in the previous example, it can be the number of people on an airplane, it can be the number of bedrooms in a house. In this example that we have down here, we're saying let x be the number of books or folders in a student's backpack. And so a student might have 0 books in their backpack. They might have 1 book in their backpack. They could have 2 or 3 or 4 books in their backpack. They might even have 5, 6, or 7 books in their backpack, okay? But notice that they don't have 4.397 books in their backpack. They either have 4 or they have 5, okay? They don't have anything in between. F of x is what we call the frequency of a specific value. So the frequency of 2 books. That's how many times that number came up in a sample, let's say, okay? So what we have here is this. How many students had 0 books? So if you look down here, How many students had 0 books in their backpack? 3 students. So 3 students had 0 books. 7 students had 1 book in their backpack. 10 students had 2 books in their backpack. 9 students had 3 books in their backpack. Okay? So so f of x is the frequency. How many times that number, how many times x came up in a sample, okay? And then p of x, that's the probability of that specific value. So in this box right here, we're going to put the probability that a person has 0 books in their backpack. This will be the probability that they have 1 book in their backpack. Okay, and it's basically what we do is to find the probabilities, we take the frequency out of the total. And so in order to, that's the first thing I want to do here is I want to identify all these probabilities here. And in order to identify all these probabilities, the first thing we have to do is we have to identify the total number of observations. And the way we're going to find that is we're going to add up all of the frequencies. So 3 plus 7 is 10. 10 plus 10 is 20. Plus 9 is 29. Plus 13 is 42, plus 8 is 50, plus 11 is 61, plus 2 is 63. So the total number of observations is 63. The probability is going to be, so the probability of 0, okay, so P of 0, the probability of 0 occurring is going to be the frequency divided by the total. Okay, that's what I said right here, based on its frequency out of the total. And so the probability here would be 3 out of 63. But we're not going to write it as a fraction, we're going to do it as a decimal. And so we're going to do 3 out of 63. 3 divided by 63 is going to be 0.04, and then we're going to round this 7 to an 8. This 6 is going to turn this 7 into an 8. So 0.048. Okay? So we're going to put here 0.048. Okay? And to do this one here, we're going to do, we're going to do 7 over 63. Okay, so 7 over 63. That's going to be 0.111. So 0.111. Now to get this number here, we're going to do 10 over 63. So 10 over 63. And that's 0.15. Now what we're going to do here, 0.1587. This 7 is going to turn this 8 into a 9. So it's going to be 0.159. 0.159. And then for here, we're going to do 9 over 63. Okay, so 9 divided by 63. That's 0.143. So 0.1428. The 8 is going to turn the 2 into a 3 because it's close, because it's 5, 6, 7, 8, or 9. 5, 6, 7, 8, or 9 will make this number go up. 0, 1, 2, 3, and 4 will make this number stay the same. So the 8 is going to make the 2 become a 3. So 0.143. 0.143. Okay, great. Now here, this probability, the probability of 4 books is going to be 13 over 63. So 13 divided by 63. And whoops, it didn't work out. What are we looking at here? 13 over 63. So 13 divided by 63. And that's 0.206. 0.206. This one right here is going to be 8 out of 63. Okay, so 8 divided by 63. That's going to be 0.12. This 9 is going to make this 6 a 7. So 0.127. 0.127. This one here is going to be 11 out of 63. All right, 11 out of 63. That's going to be 0.175. 0.175. And then this one right here is going to be 2 out of 63. Okay, so 2 out of 63. And that's going to be 0.032. 0.032. 0.032. And now if you were to add all these up, add up all of these probabilities, since it's all of them, they would equal 1, okay? So the probability of getting anything from 0 up to 7 would be equal to 1, okay? But the probability of getting just 2, that's going to be 0.159. Okay, the probability of getting just 5, that's going to be 0.127. All right, so like we were just saying, the probabilities of certain numbers, that's what this is saying here. Okay, and we have basically 4 kinds of questions that we can be asked. We can be asked about the probability that that x, the discrete random variable. Remember, x is the discrete random variable. X is just representing the number of books or folders in a student's backpack. And so this probability that x is equal to 5 is basically saying if we encounter any student, now in research we'd like to say the students that we selected in this research, that we observed. But really we're trying to draw conclusions about the students that we didn't observe. There's no use in using statistics just to understand what we have observed. We want to draw conclusions about things that we haven't observed. So what is the probability that we're going to encounter a student who has, or that when we encounter a student, what's the probability that they have exactly 5, x equal to 5 books in their book bag? Well, here's the probability, 0.127. All right, so let's look at this one here. This is the probability that x is greater than 3. Okay, greater than 3 means not including 3, because 3 is not greater than 3. Okay, so greater than 3 is 4, 5, 6, and 7. Okay, and so this is going to be equal to the probability of 4 plus the probability of 5, which we just got right here, that's the probability of 5, plus the probability of 6, plus the probability of 7. Okay, so that's going to be 0.206 plus 0.127 plus 0.175 plus 0.032, which we can do in the calculator real quick. We got 0.206 plus 0.127 plus 0.175 plus 0.032. And that gives us 0.54, or just 0.54. So that's going to be 0.54. Now this one here says x is the probability that x is less than or equal to 2. So because it says or equal to 2, we're going to include 2. And it's going to be less than 2 or equal to 2. So 2, 1, and 0. And if we add up 0.048 and 0.111 and 0.159, we get 0.318. 0.318. And now this one says the probability that x is, okay, so whenever we see this right here, whenever we see an x in between two less than symbols, that means between. So this means x between 1 and 5. So x greater than or equal to 1. So that means 1, 2, 3, but it has to be less than 5. So don't include 5. Less than 5 is 4 and 3. So greater than or equal to 1, but less than 5 means that we're going to include 1, 2, 3, and 4 only. So we would add up these 4 numbers and we would get 0.619. And you can use your calculator and verify that, okay? And this is how we take a discrete random variable probability table, and we identify probabilities equal to, greater than, less than, or greater than or equal to, or less than or equal to, and then we also do between probabilities.